This is section 6.1, part A, discrete and continuous random variables. A probability model describes the possible outcomes of a chance process and the likelihood that those outcomes will occur. For example, suppose that we're going to toss a fair coin 3 times. The following sample space is all the possible solutions or all the possible ways you could toss a coin 3 times. We could get all 3 heads, we could get 2 heads and a tail, a heads, a tail, a heads, and so on and so forth. But there are 8 different possibilities. And all of those 8 possibilities are equally likely outcomes. So the probability of each one of those is 1 out of 8. So we're going to define the variable x to be the number of heads that are obtained when you flip a coin 3 times. The possible values for x are 0, 1, 2, or 3. So how likely is x to take each of these values? So if we look at our sample space, we will get x is equal to 0 exactly 1 time. That's only going to happen if we have all 3 tails. So 1 out of all of the 8 possibilities will we get an x value of 0. There are 3 different ways we can get 1 head. The head can come first, second, or third. So there are 3 different ways out of the 8 that we could get x of 1. X can be 2. We can have the tail be last, the tail be in the middle, or the tail be first, but there are 3 different ways to get this. So again, there's 3 out of the 8 ways where we can get an x value of 2. And if x is 3, which means we have all 3 heads, there's only 1 way we can do that, or 1 out of the 8 ways. So if we take all of those values that we just had and we put them into a table, this is called the probability distribution. So if we have our probability distribution, we can then answer some questions. So what's the probability that we get at least 1 head and 3 tosses of a coin? So at least 1 is 1 or higher. So you can get 1 heads, 2 heads, or 3 heads when you flip a coin 3 times. And to get that, we can just take all of those probabilities and add them together and get 7/8. Or you can say the probability altogether has to be 100% or 1. So you can do 1 minus the probability that there's not at least 1 head. So 1 minus 1/8 will still give you that 7/8. So let's summarize everything we've looked at so far. A numerical variable that describes the outcomes of a chance process, such as x in that coin toss scenario, is called a random variable. The probability model for a random variable is its probability distribution. A random variable takes numerical values that describe the outcomes of the possible chance process. So our random variable in the last case was either 0, 1, 2, or 3. The probability distribution of the random variable gives its possible values and their probabilities. So the probability that x was 0 in our case was 1 out of 8. That's in our probability distribution. There are 2 main types of variables corresponding to 2 types of probability distributions. We can look at discrete and continuous. If we look at the discrete random variables first, this means x has to be a fixed number. It can't fall somewhere between. So you can either have 0 heads, 1 head, 2 heads, or 3 heads. But it's not possible to have 2.4 heads by flipping a coin 3 times. So this is a discrete random variable. When you have a discrete random variable, the probability for each value has to fall between 0 and 1. And all of your probabilities together have to add up to give you 1. In 1952, Dr. Virginia Apgar suggested 5 criteria for measuring a baby's health at birth: the skin color, heart rate, muscle tone, breathing, and response when stimulated. She developed a 0 to 2 scale to rate a newborn on each of the 5 categories. A baby's Apgar score is the sum of all of those ratings together, which gives a whole number between 0 and 10. Apgar scores are still used today to evaluate the health of newborn babies. What Apgar score is typical? To find out, researchers recorded Apgar scores of over 2 million newborn babies in a single year. Imagine selecting one of those newborns at random. So that's our chance process that we're looking at. We're going to define our random variable x to equal the Apgar score of a randomly selected baby 1 minute after birth, and the table below shows that data. So from this table, we need to show that the probability distribution of X is legitimate. We know the probability will be legitimate if all the probabilities together add up to 1. So if we do add all of those probabilities together, we do get a sum of 1. So this does mean that this is a legitimate probability distribution. We need to make a histogram of the probability distribution and then describe what we see. So if we make our histogram, it's going to look like this. Our histogram is heavily skewed to the left. Most of the data is over here on the right. And it's going to be very unlikely that a baby scores below a 5. So this means overall we think that babies are pretty healthy at birth. So doctors decided that an APGAR score of 7 or higher indicates a healthy baby. What's the probability that a randomly selected baby is healthy? So if they score 7 or higher, they are considered a healthy baby. So to find this, we can just add those probabilities together. And if we add those probabilities together, we're going to get 0.908, or approximately 91% chance that if you randomly select a newborn baby, that it will be healthy. Now let's check your understanding. North Carolina State University posted the grade distributions for its courses online. Students in Statistics 101 in a recent semester received 26% of them got A's, 42% got B's, 20% got C's, 10% got D's, and 2% of them received an F. Choose a Statistics 101 student at random. The student's grades are on a 4-point scale, which means an A is worth 4 points, a B is worth 3 points, a C is worth 2, a D is worth 1, and an F is worth 0 points. Say in words what it means if we're looking for the probability of X is greater than or equal to 3, and then find the probability. If we're looking for the probability that X is greater than or equal to 3, we're looking for all students who have a B or higher. And then to find that probability, we are just going to add anyone that has a 3 or higher together. So this is anyone who has an A or a B would be a probability. If you randomly select someone, the probability they're going to have an A or a B is 68%. Write the event. The student gets a grade worse than a C.
Would any staff member dress for Crazy Hair Day? Please meet outside the front of the office. Thank you. Bye.
Write the event. The student gets a score worse than C in terms of values of the random variable X. What probability is this event? So worse than a C is what's the probability that X is less than C. You could also write this as X is less than or equal to a D, which in terms of our variable is less than a 2, or it's less than or equal to a 1. To find this probability, we would just add those probabilities together, and we would get a probability of 12%. Sketch a graph of the probability distribution and describe what you see. So from our histogram, it would look like this. It is easy to see that this graph or this histogram is skewed to the left. Higher grades are more likely, but there are a few who do get low grades.